All right, let's talk about a challenge that's a massive headache for pretty much every software developer out there. What if an AI could actually dive into a huge, messy code base and fix a real bug? Not just in a textbook example, but in a real-world project. Well, today we're digging into a new open source framework called SWE-Fixer that's trying to do exactly that. But let's be real for a second. Why is this so incredibly hard for AI? If you're a developer, you know the answer in your bones. It's one thing for an AI to generate a perfect little function from scratch. It's a completely different ballgame to drop that AI into a sprawling, tangled codebase and ask it to perform delicate surgery without, breaking everything else. And this analogy just hits the nail on the head. Most of the tests we use for coding AIs are like self-contained puzzles. All the pieces are right there in front of you. But fixing a bug in a real-world repository, that's like being told there's a typo in a single book somewhere in the Library of Congress, and it's your job to go find it and fix it without messing up the Dewey Decimal System for the entire library. It's a whole different level of complexity. Now, this is where the big tension in the AI world comes into play. On one side, you've got these incredibly powerful but proprietary models, think GPT-4. They can do amazing things, but they cost a lot of money to use, and you have no idea what's going on inside. They're a total black box. On the other side, you've got the open source community. Their models are transparent, anyone can use them, but historically, they've really struggled with these super complex real-world software tasks. So the big question is, how do you bridge that gap? How do you get that big model power, but with open source transparency? Well, that's the exact problem that this new framework, SWE-Fixer, was built to solve. So what exactly is SWE-Fixer? Simply put, it's an open source system designed to do one thing really, really well. Go into a real GitHub project, find the bug reported in an issue, and actually fix it. It trains AI models to first hunt down the right files and then generate the code to patch them up. And here's the kicker. The secret sauce isn't some crazy complicated system with a dozen different agents talking to each other. Nope. The researchers behind SWE-Fixer went for elegant simplicity. The whole thing boils down to a really clever two-step process. Here's how it works. Step 1 is code file retrieval. The system uses a smart search to comb through an entire code base and zero in on the exact few files that are actually related to the bug. It's basically finding that one right book in our giant library. Then comes step 2, code editing. A totally separate, specialized AI takes a look at just those files and generates the exact code patch needed to solve the problem. Simple, right? And this simplicity was a totally deliberate choice. The researchers themselves say that by streamlining the process, it's not just easier to understand, it actually makes it much more effective to train the AI models. And this is huge. It dramatically lowers the cost of running the system. Okay, so a simple design is great, but the million-dollar question is, does it actually work? Well, let's get to the proof, because the results are honestly pretty incredible. Not just in how well it performs, but in how ridiculously efficient it is. First, let's talk numbers. On SWE-Bench, which is a major benchmark for this stuff, SWE-Fixer successfully resolves almost 33% of the issues. And that score? It's a new state-of-the-art for open source models. This simple two-step pipeline is officially outperforming other, much more complex approaches. But you know what? That top-of-the-line accuracy isn't even the biggest story here. The real superpower, the thing that makes you sit up and go, wait, what? Is its mind-blowing efficiency. And it all comes down to this one number. 2. Just 2 AI model calls. That's it. That's all it takes for SWE-Fixer to fix a single GitHub issue. One call to find the right files, one call to write the fix. Done. Now, let's put that number 2 in perspective, because this is just wild. SWE-Fixer needs 2 calls. Other leading methods, they need at least 6 or an average of 29, and one of them needs over 200 model calls to fix the same bug. This isn't just a little bit better, it's a monumental leap forward in how affordable and practical this technology can be. So, let's zoom out. What does this all mean for the big picture? Why should this matter to every developer out there, even if you're not working on AI? Well, it matters for a few huge reasons. First, it proves that open source models can absolutely compete at the highest level for these really hard software engineering tasks. Second, the team is releasing a massive public dataset of over 100,000 real bug fixes, which is going to fuel research for years. But most importantly, that insane efficiency changes the entire game. It makes powerful AI-driven bug fixing accessible to everyone, not just mega corporations with deep pockets. You can really feel the passion for community in the paper itself. The researchers put it perfectly when they say this work lowers barriers and fosters further innovation. They're not just dropping a tool and walking away. They're giving the whole community a new set of building blocks. So I'll leave you with this question to chew on. Just imagine for a minute, what does software development look like when every single developer on the planet has access to an open source AI assistant that is this powerful and this cheap to run? The possibilities are just staggering to think about.